Greetings, everyone. This particular lesson is going to be a little bit shorter than some of the other ones that we've done. And so, we're just going to keep going. But anyway, now that I've finished tripping over my own words, we are going to be looking at combining like terms. Now, it looks funny. We're going to, what's a like term and everything like that. We're going to look at exactly what a like term is. Okay, so we're going to combine like terms, and then we're going to do an activity afterwards where we get to run around the classroom and, find our little other like terms. And so I hope you guys will enjoy this. Make sure that you've got the title down into your notes, okay? Because remember, I look for that when I'm grading your notes. So the title is Combining Like Terms, all right? And so here we go. The first thing you need to know, we do have a couple of vocabulary words. You might already know them, but it won't hurt to write them down, okay? The first vocabulary word that we're going to be using a lot through this, we've actually already been using, and that's the word variable. Remember that a variable is a letter representing a number. So that's when you have like those 4A, 5Q, 6X, the A, the Q, and the X, those are variables. We don't know what the number is, so we're just throwing a letter in there kind of just to take its place for a little while. Kind of like when you take the star player off the field and you substitute them with something else. That's pretty much what we're doing. Or I should say someone else. I apologize. That's pretty much what we're doing with a variable. So make sure you have that down, and then let's move forward. Our next vocabulary term, vocabulary word. Notice I'm reading part of the vocabulary word, and that's part of the problem. Our next vocabulary word is like terms. And what it means is terms that have exactly the same variable or variables, including powers, okay? One thing that you need to know while you're hopefully writing this down, okay, is that you can have more than one variable somewhere. There can be an X and a Y put together, and that's okay, as long as they're not on different terms, all right? There can be an A and a B put together. There can be an X squared or a Y cubed. You never know until you see it. Now, we're going to be looking at a few of those a little bit later, okay? But the key is they have to be exactly the same variable or variables, including powers. Again, make sure you're writing this down. As soon as everyone's done, we'll move forward to the next screen. Here we go. All right, I'm going to kind of mark this up a little bit. So what I'd like you to do on your paper is I'd like you to kind of skip a couple lines and put this somewhere big enough where you can label it, because I'm going to be doing some labeling here. We've got a couple more things we need to talk about, because these are going to be very important when we're combining like terms. The first thing we're going to talk about is this -7 that's sitting here in front, this one right here, okay? That number, notice how it goes with the AB squared, but it's a number, whereas the A and the B are variables, right? We just talked about those. That is called a coefficient. I've actually already had a couple people say this word to me. It's a big word. All it means is that it's the number in front of the variables. Okay, so a coefficient is the number in front of the variables. It can be any number. It can be positive. It can be negative. It can be a fraction or a decimal. It can be anything, okay? The next thing we're going to look at is these AB. See those right there? Those are variables, okay? Notice how I have both A and B here. And I have the B is also squared, and we'll deal with that in a second. To combine this with something else, it's going to have to look exactly the same. It's also going to have AB squared. So it's going to have the same variables and the same power. This 2 up here, that is a power, which is also known as an exponent. And I'm going to write that a little bit neater because it looks a little messy. Okay, that's a power, which is also known as an exponent. Okay? I will point out that this exponent goes to the B, not to the A, okay? Because it's beside the B, not beside the A. There's no parentheses that would spread it out anywhere. So the way you would read this is -7 AB squared. That's the whole term put together. Negative 7 AB squared. Negative 7 is our coefficient. A and B are our variables, and our power or exponent is a 2 in this case. All right, and we've been talking about those a lot lately. I'm going to pause. If you need to write this down, give me a little wave. We can pause it, and then we'll move forward. Like I said, this particular video is going to be a lot shorter than the ones we've been working with so far because I want to have time for our activity. And so, if we need a pause, I'm going to pause now. Okay, now that everyone's had the opportunity to do that, let's move forward. Here we go. Okay, you'll see that on this page I have a list of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different terms. What I would like you to do, I'm going to pause right now, and on your paper, I want you to kind of sort these terms and put the like terms together. Okay, so I'm going to pause, and you are going to put the like terms together on your paper. And you can list them any way you'd like to. You don't have to have them all haphazard. I have them haphazard because I want them all mixed up, so it's a little bit of a challenge for you. Okay? So, again, your task, take all these terms and put them with their partners. Put them with their like terms, knowing that you have to have the exact same variable and power. So, go. Okay? Hopefully everybody's gotten the opportunity to do that. And what I'm going to do now is I'm going to talk about it, okay? So you can kind of see if you got it right. And so I'm going to take different colors and I'm going to combine things. So I'm just going to start from the left and just keep going. And so we'll, top left, and we'll go that way. So I'm starting with this 8x squared. And so I know when looking at this 8x squared that I want another x squared. The number in front doesn't matter. That's not what has to match. It's just the variable and the power. So if I look over here, I've got an n. That doesn't match. N, nope. Q, nope. M, nope. Oh, look, x squared. That one matches. So as it happens, these two go together. So 8x squared and negative 2x squared are like terms. So if we keep going, let's try some more. We go next, 3n. Right beside it, we have negative 6n. Those are like terms. We could combine those if we wanted to. Okay, if we keep going, we have 4q. Okay, what's going to go with 4q? 6q. All right, so there we go. Keep going here. Negative 3m. Well, here, this one's a little tricky because we have some 3m squareds, then we have an m, and then we have a 5m squared. So we've got this one right here, and this one right here that all have m's. But remember that when I was talking to you about combining like terms, I told you specifically that they had to have the same variable and power. Notice how negative 3m does not have a power, right? Therefore, it can't go with these over here that have m squared because those do have a power. So the sorry about that. That happens to be my dog playing with this dragon. We're going to allow them to play and squeak and have fun, and I'm just going to continue talking, okay? So we're going to go, we have our negative 3m, and then that goes with the m, okay? Because we don't have a power up here, therefore we can't have a power here either. And then last but certainly not least, we have our 3m squared that goes with our 5m squared. I'm hoping you got all of these correct and you're able to correctly find the ones that should go together. All right, and so I'm going to move forward, and what we're going to learn now is we're going to learn to add and subtract our like terms. Okay, so there's the thing we need to know about adding and subtracting. This is just one of those rules, okay? We're going to add or subtract the coefficient. Remember just a little bit ago, let me go back here. The coefficient is the number in front, okay? It's the number right here. That is the coefficient, okay? So we are going to add or subtract the coefficients, but leave the variable alone. So for example, if I had the like terms 7a squared and negative 3a squared, okay? Let's say I wanted to add these things together. All I would need to do is I look at the coefficients, the 7 and the negative 3. If I'm going to add them, I add 7 plus negative 3. Okay? 7 plus negative 3 happens to be 4. So I did the first step. Add or subtract the coefficient, leave the variable alone. 7 plus negative 3 is 4. I leave the variable alone. It's a squared. Okay? So add or subtract the coefficient, leave the variable alone. Let's try another one of these so you guys can see how it works. Let's see if I have 4xy minus a negative 2xy. Okay, so I'm supposed to leave the variable alone, so I know the variable is going to be xy. So I just have to deal with 4 minus negative 2. Now there's a catch here, and I added this in just to check it out because we've been talking about this, and we've been doing it a little bit, but not a whole lot. 4 minus a negative 2. You've got two negatives right in a row, okay? And I'm going to introduce a phrase that's going to pop up a lot. It's called subtracting is the same as adding the opposite. Keep, change, change. Anytime you have a subtraction problem, you can use that phrase. Just to remind you, okay, it's subtracting is the same as adding the opposite. Keep, change, change. Yes, I normally sing it in class. Maybe you'll sing it along with me, and maybe you won't. I'm going to say it one more time. I want to hear your voices, because remember, even though I'm on here, I'm in the classroom too. So are you ready? Subtracting is the same as adding the opposite. Keep, change, change. And so now let's use that. Okay? Subtracting is the same as adding the opposite. So that means we're going to keep the 4, change the negative, and change the other negative. So keep, change, change. Therefore, it becomes 4 plus 2, which is 6. So your final answer here is 6xy. I'm actually going to sign out of this video now because what we are going to do is we're going to turn to an activity in class that's going to be loads and loads of fun for me. I don't know how much fun it'll be for you, but hopefully it'll be just as much fun for you. So I'll turn it back over to myself standing in the classroom, okay? Bye.